Welcome viewers. In this video we will see the SI units. What is meant by SI unit? What are the units are available? We'll see in this video. The SI is nothing but it is the abbreviation of the French word Système International. The international level the standards are defined so that everyone need to use the same standard for the uniformity. Entire universe, in order to get the uniformity we have SI units. That is the abbreviation of Système International, that is from the French word. That is nothing but international system of units. SI is nothing but international system of units, is the metric system that is used universally as a standard for measurements. In order to get the uniformity over the entire universe, these SI units are defined. So everyone need to use these SI units for representing the measurement. The SI unit plays vital role in scientific and technological research and development. In order to we have the uniformity, so that while going with any research and development, it will be very useful in order to go with the uniform standards, uniform units. So there are 7 base units are available and 22 derived units are available. The 7 base unit means it is a basic. There are 7 basic units are available. From the base unit, there are 22 derived units are available, and some more derived units also available from the base. By standard, we have 22 derived units. See, these derived units are obtained from the base unit. So only these 7 are base units. All other units are derived from this base unit. So that it is called a base unit and derived unit. This SI unit can be expressed as either as a standard multiple or fractional quantities. Standard multiple or fractional quantities. These quantities are defined with the help of prefix multipliers with the power of 10. That is ranging from 10 to the power minus 24 to 10 to the power plus 24. Right? So these SI units are represented as standard multiple or fractional quantities. That is, what is that standard multiple and fractional quantities? That is power of 10 on both the side, negative as well as positive. 10 to the power minus 24 to 10 to the power plus 24. Right? Now we'll see what are the 7 basic units, what are the 22 derived units, and what is the range from minus 24 to plus 24, how the units are represented. That also we'll see in this unit, in this video. So base unit means a fundamental unit or considered as building block of the system. So this is a fundamental units. All other units are derived from this base unit. It is a building block. From that only other units are derived. So the derived unit means the derived unit is a unit of measurement in international system of unit that is derived from one or more of the 7 base units. So only this 7 base unit is the building block for all other derived units. All other derived units are obtained from these 7 base units. Now we'll see base unit, derived unit and multiples one by one. First we'll see the SI base units. So there are 7 SI base units are available. We'll see one by one. The first one will be length. The unit is meter. The symbol is M. First one is the length. The unit is meter. The symbol is M. How it is defined? How internationally defined the length? It is defined by making fixed value of the speed of light in vacuum. Right? We know what is meant by 1 meter, 2 meter mean we know, but how it is defined 1 meter, what is internationally defined, what is 1 meter? We know what is 1 meter by seeing the scale or the tab, you are easily identify meter, but how it is defined internationally is nothing but taking fixed value of the speed of light in vacuum. That is a reference. 1 meter means it's a speed of light in vacuum. right? So the first one is length, unit is meter, and symbol is m, that is defined by fixed value of speed of light in vacuum. The second one, mass, kilogram, the unit is kilogram and symbol is kg. So while purchasing any product, any material, we are referring with kilogram or gram. So that is the second one, mass. How it is defined internationally? Defined by taking fixed value of blank constant. From the constant only we define what is 1 kg. While going to shop, we can know the 1 kg material is available. But how it is defined by 1 kg is nothing but a fixed value of blank constant. That is important, right? This is previous one, speed of light. This one, constant. The third one is time. The unit is second. Yes, we know that the time is measured by either second or minute or hour. The base unit is second. But what is second? By taking the fixed value of cesium frequency. The cesium frequency is the reference. 1 second. 1 second is defined internationally by cesium frequency. Right? So these are all the three standard. How they are defining also available. Speed of light, Planck constant, cesium frequency. From this we are able to know what is 1 meter, what is 1 kilogram, what is 1 second. We are able to easily identify. Universally we are following the same unit for these quantities universally. We'll go for further some more another SI units. The fourth one is the electric current. The symbol is I. Ampere, the unit is ampere and the symbol is A. What is how it is defined internationally? Defined by taking the fixed value of elementary charge, right? The fixed value of elementary charge will define the current. From that we are easily measure this is 1 ampere, 2 ampere, 3 ampere. But internationally what is meant by 1 ampere is fixed value of elementary charge. Then thermodynamics, temperature, theta. The unit is Kelvin, the symbol is K. We know that the temperature measured in Kelvin. Another one Celsius available, but Kelvin is the base. How we are measuring this Kelvin? Defined by taking fixed value of Boltzmann constant. Since this Boltzmann constant will define the temperature Kelvin, 1 Kelvin. That is K equal to 1.380649 into 10 to the power minus 23. So that will define the Kelvin. The next one is amount of substance. The unit is mole, symbol is MOL. What is that amount of substance? How it is defined? Fixed value of Avogadro constant. So this constant, Avogadro constant, will define the amount of substance. Then luminous intensity. The intensity means the lighting. What is the intensity? The unit is candela, symbol is CD. We know that this bulb is very bright, this bright is less. We are easily telling the luminous, but it is defined by fixed value of luminous efficiency. From luminous efficiency, we are defining the candela. So these 7 are the very basic SI units. All other SI units are derived from these base units, right? So what are the things are there available? Length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. For all, symbol and units are available, and how it is internationally defined also the details are available. Now we'll see the SI derived units. 22 derived units we'll see. All these derived units are available from these base units. Okay, now we'll see the derived units one by one. So this is the name, symbol, quantity, and SI base units. From which base unit we are getting this? That is nothing but SI base unit. It's a combination of one or more base units. The first one is hertz. The symbol is Hz. What is the quantity? Frequency. The frequency is measured in the unit hertz. It is represented by Hz. What is that? S power minus 1. The base unit is S power minus 1. Next one, angle. It is measured by radian. The symbol is rad, R-A-D. That is 1. The base unit is 1. For angle, we have one more angle, solid angle. Steradian, SR. Steradian, SR, that is used for solid angle. Normal angle referred by radian. That also, the base unit is 1. The fourth one, Newton. That is for measuring the force. The unit is Newton. Symbol is N. For force, but the unit is Newton. The symbol is N. What are the base units here? Kilogram, meter, and S power minus 2. This is nothing but second. S power minus 2. So see this, there are 3 base units are available to define the term force. kg dot m dot S power minus 2. Then for measuring the pressure, you have Pascal, PA. For measuring the pressure, the unit is Pascal. The symbol is PA. What are the base unit? kg dot m power minus 1 S power minus 2. Kilogram, meter, and second. kg dot m power minus 1 S power minus 2. It's available for pressure. We'll go some more. Next, energy. Energy, the unit is joule, represented by J. For measuring the energy, the unit is joule. It is represented by J. What are the base unit? kg dot m square dot S power minus 2. Right? kg m square S power minus 2. Then power. For power, the unit is watts. Watt. Represented by W. What are the base unit? kg dot m square S power minus 3. S power minus 3 for a power. Then electric charge is defined, is given, the unit is coulomb. The symbol is C, electric charge. What is that? S into A. S into A is a base unit. Then voltage is measured as, unit is volt. The symbol is V. What are the base units available? kg dot m square S power minus 3 into A power minus 1. These are all available for voltage. Then capacitance is measured with the unit farad. The symbol is F. kg inverse m power minus 2 S power 4 A square. That is a base unit for capacitance. Then we'll go to the resistance. Resistance, the unit is ohm. The symbol, this is the symbol. What is the base unit? kg dot m square S power minus 3 A power minus 2 for resistance. Similarly, conductance. The resistance and conductance are inverse. Is Siemens. Conductance is given Siemens. The symbol is S. What is the base unit? kg minus 1. kg power minus 1 m power minus 2 S cube A2. That is for conductance. Then magnetic flux is, the unit is Weber, WB. The symbol is WB. The base units are kg dot m square S power minus 2 A power minus 1. Magnetic flux density is given as Tesla. The symbol is T. Magnetic flux density, Tesla. kg S power minus 2 A power minus 1. Right? The base units are kg S power minus 2 A1. Then inductance. Inductance is, the unit is Henry. The symbol is H. kg m square S power minus 2 A power minus 2. The base units. Then temperature in Celsius. Already in base units available as Kelvin, but here is Kelvin. And one more unit is Celsius. Right? The base unit is K. 273.15 K. Right? So the Kelvin available in base unit, Celsius available in the derived unit. The next one is the lumens. What is the luminous flux? Luminous flux, the unit is lumen, is CD, candela. Then illuminance is lux. The symbol is 1x. CD dot m power minus 2. Then another 4 are available. Radioactive decay per unit time. Right? So the radioactive decays. These are all based on the radioactive radiations. Right? Becquerel is the unit. BQ is the symbol. S power minus 1. Observed dose of ionizing radiation. Gray, GY. M square S power minus 2. Equivalent dose of ionizing radiation. Sievert, SV, S power minus 1 mole. Then catalytic activities. That is Catal, KAT, S power minus 1 mole. So these are all the 22 derived units. These 22 derived units are obtained from the base unit. Now we'll see the multiples and submultiples. That is 10 to the power minus 4 to 10 to the power plus 24 available. We'll see the terms one by one. So we'll see what is the prefix for multiples and submultiples. How these units are represented with the prefix. First we'll see the start from 10 to the power minus 1. Then we'll go to this. These are all negative. We'll go to positive later. First we'll see the negative. 10 to the power minus 1 is prefix is deci. The character is D. D, deci means it is represented 10 to the power minus 1. 10 to the power minus 2 means centi, C. 10 to the power minus 3 means milli. The symbol is M. 10 to the power minus 6 is micro. The symbol is mu. 10 to the power minus 9 means nano, N. 10 to the power minus 12 means pico. The symbol is P. 10 to the power minus 15 is nothing but femto. The symbol is F. 10 to the power minus 18 means atto, A. 10 to the power minus 21 means jepto, Z. 10 to the power minus 24 means iacto, Y. So we can represent the units by using this prefix starting from 10 to the power minus 1 to 10 to the power minus 24 available. So we can represent using this. Similarly, the positives, the multiples also available. 10 to the power 1. 10 to the power 1 means deca, DA. 10 to the power minus 2, 10 to the power 2 means hecto, H. 10 to the power 3 means kilo, K. 10 to the power 6 means mega, M. So these are all multiples that are the previously what we did is submultiples. 10 to the power minus 10 to the power 9 is a giga, G. 10 to the power 12 is tera, T. 10 to the power 15 is peta, P. 10 to the power 18 is exa, E. 10 to the power 21 is jetta, Z. 10 to the power 24 is iota, Y. So here is the multiples available from 10 to the power 1 to 10 to the power 24. So in this video we discuss what is SI unit, what is SI base unit, what is derived units, and we discussed the 7 base units, 22 derived units, and also multiples and submultiples. Thank you.